I think we're good. I turned Wi-Fi off. I turned Wi-Fi back on. I'm hoping that that refreshes my connection enough, but it was running too slow and the embedder keeps disconnecting. But I'm hoping we're good now. No, it's still saying live stream offline. Alright, it looks like we're good. It seems like it's streaming correctly again. I don't have a lot of you left at this point. Do you want to say hi if you're in the chat so I know who we have with me? Alright, so I'm sorry for the tech difficulties. I'm trying to figure out how to turn the live chat back on. At this point, you should be trying to work out the volume formula for the cone problem. The next shape we're working with is a cone, so figure out what's the volume formula I need to use for that. And also, how to identify, or once I have that formula, how do I figure out the volume for it? So hopefully at this point you've worked out the volume for the cone. The second problem that we have there, the volume formula for our cone is going to be V equals 1/3 times pi times radius squared times height. You'll notice that formula is a lot like the cylinder formula. It just has 1/3 as a coefficient with the pi r squared h. So for this cone, our radius is 5. We have a radius of 5 meters on the cone. We have a slanted height of 13 meters on the cone. And the challenge for this problem is going to be we need to recognize that if they've given us the slanted height and the cone formula asks for height, we're actually going to have to first use Pythagorean theorem to find the missing side length there. So if that's the case, if we have a triangle, I'll go ahead and draw that on our whiteboard. That is 13 by 5, and it's a right triangle. Would remember a squared, 5 squared plus b squared equals 13 squared. If you remember doing Pythagorean theorem a couple months ago. I'll make that whiteboard a little bit bigger so we can figure out the missing side, which is really going to be the height of this cone. And so 5 squared gives us 25. 13 squared gives us 169. And when we subtract 25 from both sides, some of you may remember the 5, 12, 13 triangle. We get b squared equals 144. And if b squared equals 144, then that means b, the height, is actually going to be 12, because 12 times 12, or the square root of 144, gives us 12. So the really tricky thing to see for this cone was that the height is actually going to be 12, and the radius is going to be 5. So again, the height is going to be 12, based on the Pythagorean theorem. The radius is going to be 5. And then once we know that, our volume formula of 1/3 times pi times radius squared times height could be used. So now that we know that the radius is 5 and the height 4 times 25 is going to give us 100, so we have 100 multiplied by 3.14 because that's what we're told to use for pi. And that gives us a volume of 314. In this case, it's measured in meters. So that's going to be 314 cubic meters for our volume. And again, if we have a height of 12, a radius of 5, the volume here works out to 314 cubic meters. So I'm going to give you another minute or two to now try to work out the volume formula for this next shape, identify the name of the next shape, and then also identify what is the volume formula that helps me here, and take some time with your own whiteboard or your own paper and pencil to work out what's the volume for this last shape going to be. Hopefully by this point you've identified the name of the last shape, the name of this last shape, anything that looks like a ball, whether it's a basketball, whether it's a soccer ball, whether it's a volleyball, whether it looks like a globe like the Earth, which is pretty close to a perfect sphere. The volume formula that we're going to use for the sphere is a little bit more complicated. It's volume equals 4/3, that's our coefficient or our fraction, multiplied by pi, multiplied by radius raised to the 3rd power. Because the sphere doesn't really have any height, like our cone or like our cylinder, the radius serves as both the length, the width, and the height for our sphere. The radius is raised to the 3rd power, and our coefficient's a bit more complicated. We need to multiply by 4/3. So if that's the case, if that's our volume formula, the only thing you need to know to determine the volume of a sphere is what is the measurement for the radius. In our case, the radius halfway across the sphere is 5 inches. So our volume formula, 4/3 times pi times radius cubed, could be changed to V equals 4/3 times 3.14, which is what we're going to use for pi, multiplied by 5 raised to the 3rd power. The radius is 5, so 5 is going to get cubed or raised to the 3rd power. I'm going to make the whiteboard a little bit bigger to make this easier to see at this point as we work out the volume of that sphere. The first thing I would probably do is I would evaluate the exponent, following order of operations. 5 to the 3rd power, or 5 times 5 is 25, and 5/4 is worth $1.25 or 125 cents. So I get 4/3 multiplied by pi, which we're using 3.14 for here, multiplied by 125. And for me, the easiest way to multiply, I would handle the 3.14 last. I would do 125 multiplied with 4/3. And anytime I multiply with a fraction, I simply take the number and I multiply by the numerator, the top of the fraction. So I would do 125 times 4. And then I would divide by 3. 125 times 4 divided by 3 is the same thing as taking 125 and multiplying it by the fraction 4/3. When I do 125 times 4, that's going to give us 500. So it really becomes 500 after you do 125 times 4 divided by 3 multiplied by pi, multiplied by 3.14. So at that point I'm going to use a calculator. I'm going to take 500 divided by 3, and I'm going to be careful to use parentheses here. After I do 500 divided by 3, I want to multiply by 3.14. So when I do 500 divided by 3, multiplied by 3.14, we get something just a little bit bigger than 500 if we divide by 3 and multiply by a little more than 3. We get 523.3, and now that 3 is repeating the rest of the way. This is measured in inches, so this is going to be cubic inches for our final answer. The volume of that 5-inch sphere is going to be 523.3 cubic inches. So there's our volume for the sphere. That 3 would be repeating. I'm going to use a ... after a few of the 3's just to signify that that 3 keeps repeating, but you also could just round this off to say about 523.3 inches cubed. At that point, hopefully we're ready to move on to the second and the third problem. So take a little bit of time now that we've worked through that first problem to try to figure out the answer for problem number 2. Alright, so for that second one, hopefully you've identified that it's a cone. One of the big things to see first off is the correct shape and the right formula, so we're working with a cone here. So I'm going to go ahead and use the cone formula, which is V equals 1/3 times pi times radius squared times height. So that's the formula we need to be selecting for the cone. The two important things to know for this cone is what is the height and what is the radius. We have a height of 7 inches. I'm going to put that down here, h equals 7. And the radius, which we also need to know for the cone formula, they provided us with the diameter, which is 8 inches. If the diameter is 8 inches, that means the radius is half of that, or the radius is going to be 4 inches for this particular cone. So a really important thing for number 2 is to recognize the radius is 4, and the height is 7, so I'm going to plug in a 4 for the radius and a 7 for the height. So this becomes V equals 1/3 multiplied by pi, which we'll use 3.14 for, multiplied by 4 squared, because the radius is 4, multiplied by 7. At that point, we just need to do the math out. I'm going to make the whiteboard a little bit larger as we work out the volume of this cone. We had 1/3 times pi times radius squared, and the radius was 4, times a height of 7. So if I do 4 squared, that's 16, and if I do 16 times 7, 16 times 7 gives us 112. So we have 112. The volume is going to be 1/3 times pi, which is 3.14, multiplied by 112 at that point when we done 4 squared times 7. So now when I do 112, it's going to get divided by 3. That's really all that happens when I multiply by 1/3. So I'm going to take 112 divided by 3, which gives me 37.3 repeating, and then that needs to be multiplied by 3.14. So I multiply by 3.14, and that gives me a final result, or a final volume, of 117.266, and that 6 keeps repeating, so I'll just put a line over that. Now as I go through the multiple choice, try to see which one lines up with my answer. And I may have made a mistake today as I wrote that. It looks like we'd get 112 times 3 divided by 3 times 3.14, which would give us 117.226. So I missed one of the 2's there. And now we see 117.226 is going to round up to be 117.23. If you ended up at one of these other answers, it was likely because you either used the wrong volume formula, maybe you did not identify V equals 1/3 times pi r squared h as the cone formula, or perhaps you used 8 as the radius when 8 really represented the diameter, which resulted in your volume being too large in one of these other answers. So at this point you should be moving on to the third problem. I'm going to give you a minute or two to try to work out that third problem, and again I apologize that the chat's a little messed up and we can't hear from you all with what answers you're getting. We'll fix that tomorrow. Okay, hopefully at this point you've identified for problem 3 that we're working with a sphere here. This ball-shaped figure, the purple shape on problem 3 is a sphere. So the volume formula, if they're asking us to find the volume for this shape that we're going to use, is V equals 4/3 times pi times radius cubed. So since this is a sphere, I'm going to go ahead and copy my volume formula for a sphere. V equals 4/3 times pi times radius cubed, or r to the 3rd power. The big thing to recognize here, I'll note on my whiteboard, we need to figure out what is the radius for the sphere. If I know the radius for the sphere, then I can determine what the volume is. In this case, they provide us with 42 centimeters, but the 42 centimeters that they're showing us here, that 42 centimeters represents the diameter. So if the diameter is 42, that means the radius needs to be half as big as that, or the radius needs to be 21 centimeters. That's the big first thing to understand for problem 3. Once I know that the radius is 21 centimeters, I'm going to take that radius of 21 and I'm going to plug that radius of 21 into the formula. The volume of the sphere will be equal to 4/3 multiplied by pi multiplied by the radius, which is 21 in this case centimeters, raised to the 3rd power. I'm going to make that whiteboard a little bit larger. So again, the volume of this sphere is determined based on the radius, which is 21, so we plugged in 21 for the radius. I need to do 21 to the 3rd power. I don't want to multiply that out by hand, so I'll go ahead and use Google's calculator. 21 raised to the 3rd power, or 21 times 21 times the 3rd. 21 is going to give us 9,261. That's still going to get multiplied with pi. That's still going to get multiplied by 4/3, so I bring the rest of the formula down. The volume of this sphere is equal to the 21 cubed, which is now 9,261, times 4/3 divided by pi. So at that point, I'm going to go ahead and do 9,261, multiply it by 4, and then divide by 3. That's going to give me 12,348. So again, to multiply by 4/3, all I do is I take my number here, 9,261, and I multiply by 4, then divide by 3. That produced 12,348. That 12,348 still gets multiplied by pi, which I'm going to switch to 3.14 at this point. So I'm going to take 12,348 and multiply that by 3.14, the estimate that we're using for pi. When I do that, the volume formula for the sphere produces a number of 38,772.72 cubic centimeters. As you look through your choices, that's option C here. If you did this problem on your own and you ended up at one of the other answers, A, B, or D, it was likely because if you ended up at D, you probably did not realize that the diameter was 42. You had to cut that down to 21 for a radius. If you ended up at one of these other answers, perhaps you made a mistake using the formula, or perhaps you just grabbed the wrong formula entirely. So again, our correct answer here was C. If you ended up at answer D, that's probably a result of using 42 as the radius instead of 21. And if you ended up at A or B, you probably incorrectly used the formula or did r squared instead of r cubed, something like that. Problem 4, problem 5 get a little trickier. So as we move from number 3 into number 4 and 5, the 4th problem and the 5th problem, they really focus on what IXL and Khan Academy will get to on their tougher problems towards the end. Instead of asking you to find the volume for a shape, they're going to give you the volume for a shape and ask you to try to determine the radius, the height, one of the other dimensions for that shape. So we're going to go ahead and give you a couple minutes to try to work out that 4th problem on your own. 4 and 5 again get more challenging because now they're going to start providing you with the volume for the shape and ask you to use the volume and the formula for the volume to determine one of the other dimensions like the radius or the height for that shape. So I'll give you a minute or two there as you're working that out. And then I'll rejoin you and we'll go ahead and work through the fourth problem together. But hopefully you can try to arrive at the answer for the fourth problem. And once again, my apologies that the chat's a bit messed up and we can't be chatting through these problems as you're working through them with me. Alright, so for this fourth problem, the shape that they provide us with on the fourth problem is a cylinder. So the volume formula that we're going to be using or working with a cylinder remains the same. It's going to be V equals pi times radius squared times height, which I'll copy on the whiteboard right now. But the difference this time is they've provided us with the volume of this cylinder. They've told us that the volume of the cylinder is 254.34 cubic centimeters. And we also see that the height, right here, the height of this cylinder is 9 centimeters. So the two numbers I'm going to have to plug in this time, I have a volume of 254.34. And I know the height is 9 centimeters. We'll go ahead and show very quickly again, the height is 9 centimeters there. So if the height's 9 centimeters and they want us to figure out the radius, I'm going to plug in the 9 for the height, I'm going to plug in the 254 for the volume. And I don't know what r is yet, so I'm just going to leave that as r squared. In this case, I know volume, so this time the v gets replaced, but I don't know radius. And what's a little more challenging now this time is the formula is better built to solve for volume. It's built, it says volume on one side, radius, height, pi, everything on the other side. So if I need to solve for the radius or the height, I need to use my equation solving skills, or peeling the onion if you think back to last year's vocabulary. So the first thing I'm going to do, I'm going to change the pi into 3.14. As pi, we're going to use 3.14 for most of the time, including this problem. And I'm going to do 9 times 3.14. Because on that right side of the equation, I do have two regular numbers, two constants, 9 and 3.14, so they can be multiplied together first. That gives me 28.26,